by means of data posting. I came from a just a bit different research field, and I was surprised on how interesting was this conference in mixing practical aspect and theoretical aspect of logic. And so when preparing these slides, I was thinking, what should I say to make it interesting for a so different community. First, I will introduce you to the big data challenge not in the usual way, because you always listen to this word and many papers and many conference focuses on this big data, but trying to sell different brands for the same argument. Then I will introduce you to the basic of our approach that is based on count constraints. This is a particular form of constraints that is useful in our context. Then I will show how we model research dimension in this case through data posting. Then I will draw some conclusion. First of all, the basic point is that we are overwhelmed of data. Data everywhere from users are always connected, and they generate a lot of useful data, but quite difficult to manage because they are data about actions that users do. For example, rating a restaurant or a hotel, or just a like or a heart on Instagram or whatever you want, and they have a high informative content that unfortunately is quite unstructured. So probably you have seen this slide. It's not mine, because big data is a so abused term that every time that there are two different thinking about this. Okay, don't say big data one more time, otherwise I will kill you. Or there is the positive, the interpretation of this word. Okay, I will write something. It's better to include the big data word in my paper. It's safer. But my interpretation of big data, since I came from the database community, is this. It could have a pessimistic vision of big data. Okay, you have a large volume of data, they come at high speed, so you have velocity, and they are really heterogeneous, so you have variety. And this was the initial 3V paradigm of big data. But an optimistic vision, also this slide, I took from a conference, but it's quite nice because it is a logical implication about big data. So big data is like teenage sex. We are all adults, so everyone talks about it. Nobody really knows how to do it. Everyone thinks that the other people are doing it, so everyone claims that they are doing it. Why I'm telling this? Because, and why I came to this conclusion, because the last B, the most important B, is value. Here we have people coming from the industry. When I started working on this field, and I met some for projects, some managers or even of small or big industry, the first question is, where can I buy a big data? So the problem is that we have to use data to give them value. So how can we turn these huge amounts of data into value? No matter what you do, I want explanation, but this is the problem, and here comes the useful link with logic. With big data, you lose the causality because you have so much data, so you cannot draw immediate conclusion about what you are investigating. In this particular paper, we addressed the problem that comes up to us in the context of a huge research project. This project was called InMoto. It was information mobility for tourism, and we tried to analyze tourist flow and to understand how tourists interact in our region at first, because we have data about them, and then how to figure out a more general framework for analyzing, especially user search. Why user search is so interesting? Because Usually you can behave in two ways. You can have a Google style search, so keyword based. You type something and you wait for the result, hopefully, and facet search. When you use some hints, the information is categorized using some sort of ontology. But the problem is that users don't really know what they are searching for, or they don't have a clear idea in mind of what it's useful for related to their search. So we figure out a possible solution by taking advantage of another important phenomenon that is arising nowadays, the fact that people are influenced by others' choice. So we need to, when performing search, we need to derive a new dimension search, like the keyword suggestion of Google, or like the facet proposed by Yahoo directory once, and then from many other specific search engine. But we use the framework that is called data posting. So it is based on count constraints that are basically constraints about the extent, the cardinality constraints, and it's a special case of data exchange to a target fact label, and that is based on the use of discount constraints to add new dimensions. So in particular, we need to use an additional domain schema that describes the search the search domain we are trying to index, and in particular we need to know, in order to do some new information, to know information about the overall domain. What I mean, when you search on TripAdvisor or Google, they suggest you some keywords related to the one that you are searching for. And for TripAdvisor or booking specialized engine, they have some predefined categorization. So the dimension is built in within the engine. So what if you try to take advantage of the content of that information? I will explain better. Suppose that I'm saying in a post that in a given restaurant they serve good pasta, very good pasta, but the meat is not so good. This restaurant, how has to be classified? Is it a good restaurant or a bad restaurant? It depends on what you are searching for. If you are searching for pasta, probably this restaurant is good. If you are searching for meat, it's not. So we have to try to extract useful new dimension from the data that are hidden in the post. So it's rare that a user searching for something read all the posts. Usually read to the stars or to the proximity to the place where he is actually. So how count constraint can be exploited? Posts are basically textual information that can be easily clustered, and once you cluster data, you have some concept that emerge. How you can weight this concept, for example, good pasta or bad meat? You can use discount constraints that take advantage of this interpreted count operator that assess that a certain value has to be within a given range. Not that in a classical data exchange this is not the usual setting, because in classical data exchange you have to obtain a universal solution, so the count is always one. So in this sense we extend the classical data exchange, and we introduce some form of non-determinants, because we don't have anymore a fixed number of results. So the basic component of this data posting setting are the source database schema that has his own relation schemes, and a domain database schema that has to be inferred or derived from some background knowledge about the data, and a target flat table whose attributes domains are in D. Well, why we need to obtain this flat table? Because as a nice side effect we can obtain, if we are able to properly collect data in this table, we can use a kind of OLAP analysis, online analytical processing, that is easily to use also for non-expert user, and it's able to give a first glance information for domain expert, for example. So consider an example in which we have some relation about restaurant with the attribute whose attributes are the name of the restaurant and the average price, the user review post, that is the post identifier, the user who posted the post, the restaurant name, the post refers to, and the evaluation, that could be of different type, and we have a database relation, that is the restaurant category with the average price, the evaluation, and the category value of the restaurant. While the target schema is the classification of the restaurants with the restaurant name and the category value, and the classified post with the post identifier, the user, and the classified review evaluation. So possible count constraints for this simple schema, for example, may say that here we say that if the post is different from not applicable, so the information the restaurant has been categorized, this information has to be validated by at least 10 posts, and while the second rule says that if the category will be not applicable, the first rule must be violated in all other cases, and the third rule, count constraint, says that you have to choose the higher frequency one, while the last one is a kind of implementation of the functional dependency. In the case of tie, you can choose one of them. So, the constraints that I just showed you it's called source to target. It could be source to target constraint. That is a dependency where the formula models this information, that the results, the count, should be in a given interval. While a target count constraints differs from the source to target constraints for the fact that the formula is a conjunction of atoms with T as predicate symbol, with T is the target schema, and the data posting setting, to sum up, it can be considered as the three source database schema, domain database schema, and target platform table, and a set of source to target count constraint, and a set of target constraints. And so the data posting problem is finally given a finite instance for S and for D. We have to find the finite instance for T, such that both IS, ID, and IT satisfy both the source to target constraint and the target constraint. As I already noted, the main difference with respect to classical data exchange is the presence of a domain database scheme that stores the new dimension that eventually emerged by analyzing the background knowledge and the data, in this case the post, that are added while exchanging the data. So if it comes up that a good categorization will be not simply include the stars or the prices there, but the classification of the different food they serve, included this new dimension in the domain schema. So in a sense, we can say that data posting is a process of enriching the data while exchanging them. Going to the conclusion, our approach has been used in a scenario that is the tourist scenario, where we had an interesting ground of knowledge, because we have a post, we have interaction, and also we were able for a while to get, for research purposes, the anonymized calls, telephone calls, to model also the interaction between users. And we use the big data approach because the underlying system architecture is based on, of course, on HBase, and we use a lot of tools to implement the functionality of this system in order to be effective, but also efficient, because we have to offer timely answers to the users. While a future interesting research line, the one in red, could be the one of modeling non-progressive feature. That is really interesting also from the logical point of view, because a user usually change their mind. What that means? Imagine the case of people that I know a lot of people that do this, that eat a lot of meat. Okay, then suddenly they became vegan. Okay, what will happen to the post of that person? Probably will never rate high restaurant that serve meat, but they will prefer. And modeling such a feature is a quite intriguing and difficult task. This is called non-progressive modeling, and it's kind of alternating approach to the user behavior. And it's one of the main reasons for which viral marketing doesn't work. One of my co-authors had spent 1 year of PhD in Vancouver, working with Professor Lachmanan, and they actually comes out with this conclusion that viral marketing, actually with the actual instrument, without modeling non-progressive feature, is basically wasting a lot of money. The money was because it's not effective and cannot model how users influence each other, even when they change their ideas. Thank you, and I'm waiting for your
So did you actually implement this system into a real system?
Yes, we have an old prototype that is based, as I told you, the data are stored on HBase. That is useful because basically HBase use text file, use HDFS, so search of data for building the ground truth for the listening model is easy. Then we can take advantage of some add-ons like that are available in the framework, such Lily Indexer, that comes also from Apache, that allows to fast indexing on Word. They provide a clustering algorithm that is called Lingo, and it's quite efficient also because it's built in the system, so you quickly have the system. And finally, you can have a nice presentation with the system that is called UE. And so we have actually implemented this, and we used the data that we had. Indeed, we were lucky because we can use, in this project there were a part that is called education, and we had to involve students to teach them about big data, about the influence, about tourism, and it's a broad part of this, a broad set of arguments. And then we asked them to act as a user, so they share their profile built for these purposes, and they use the profile, so we were able to collect real Twitter, Facebook, and in a controlled environment, of course, but you can imagine that you can easily access the tree, because especially in Facebook, if you have the authorization to have the node, you can use the post on the node.
The lower and upper bound are set at the same time, define
Okay.
data volumes.
No, okay. Usually they are asked to they are set at the same time. We ask to the domain experts, for example, depending on the context, we set some predefined threshold, but in principle it's possible to derive it at runtime by analyzing, to infer it at runtime by analyzing the data flows. That is where big data velocity features can start.